Now, let's take a look at hashing. Hash functions are just like blenders when you're making a smoothie. You put in your data, like fruit, and then crush it and whiz it up and voila, it comes out something new. And most importantly, just like you can't unblend the original fruit from your smoothie, you can't restore the data to its original format once it has been hashed. Just like blender models, different hash functions will give you different results. Let's take a look at some examples. Some of these hash functions are really outdated and not safe for use, but let's see why. You may have heard that the MD5 function is unsafe. The SHA1 is also not a secure function. Why? Because both of these algorithms are vulnerable to collisions. In a normal situation, two different files have two different hashes. But with these two functions, it sometimes happens that two different files are created with the same hash value. So it's better to avoid these algorithms and stick to the secure hash functions instead. Hash functions have many uses, but they are most commonly used in two ways. The first is for storing passwords, because hashes are one way, and it's impossible to restore an original password knowing just the final hash value. It will be necessary to go through the password database and check all their hashes. The second way is integrity checks. But in this case, you should bear in mind what we said about collisions and choose the proper algorithm accordingly. Let's have a look at the basics of integrity verification using hash functions. Let's say that user 1 wants to send data to user 2. They both know the same key, so they can collect a hash from the message and check its integrity. After user 1 has collected a hash from mixing the message with a secret, they send the data to user 2. User 2 receives a message with a hash and collects their own one based on the message itself and the key known to both users. And if the two hashes match each other, that means the message is not a fake. All sounds great, right? But unfortunately, there is a big problem with this scheme. Since the key is shared, outsiders can get their hands on it. And this outsider can replace the message and sign it without the receiver having any idea. For this reason, the method is not appropriate when you need to be absolutely sure who wrote the message. Here are our recommendations for using hash functions. First of all, use hashing to store passwords and check the integrity of JavaScript libraries. And secondly, avoid any schemes which only use a single secret key. If you need to be sure that a particular user sent the data and no one else. This will help you to protect your company from leaks, protect your data correctly, and to protect your customers from account theft, unauthorized access, and viruses.